And here we go.
There's the W. Here's ignition.
Roger, roll, Atlantic. Doubling up.
Did he just do a Kerbal?
Back to the moon and beyond.
Put that in the big bag, you know.
Back at home, we all have a lot of work to do, but from here, that sure looks like a perfect flow.
Propulsion continues to be nominal.
We did have an observation.
Equalize.
343 unfolds to go.
It's orange.
Water towers can fly!
Bingo! Right in the center. Where's Jacqueline? There it is!
That was surreal.
That's not what we want to see.
No!
Oh my God.
Yikes. You bet. Sure. We don't need any more of these.
All right, folks, you know the drill. It's a Sunday, and we are live with an Intrepid Museum Astro Live. You know what we do. We get cool folks from NASA, engineers, scientists, people who have a lot of cool information to share with us. But today, we're going to get into some details of some research that NASA has been working on, because the big question is, you know, NASA does research. It's one of the many things that they do. How much of it is useful in helping us get back to the moon, let's say more quickly, right? You've got two sort of schools of thought. Well, these days there's an awful lot of success in commercial spaceflight. You see SpaceX and Falcon 9 and all this stuff that's going on. But that doesn't mean that NASA's decades of experience has completely been made obsolete, because physics doesn't change, right? And so today we're going to talk through some of the research, some of the specific projects that NASA has been working on for years that will be leveraged to get us back to the moon in a more sustainable manner. We say permanent manner, we say back to the moon to stay, right? Well, today we're going to look at some of this research and some of the technologies, because we have a special guest directly from NASA, Marshall Space Flight Center today, who's been involved with a lot of these different research and engineering problems, solutions, that sort of stuff, that will hopefully talk us back over. But you've seen, right, the PowerPoint presentations. You know, Jared Isaacman has been on the big presentation saying, oh, you know, NASA has these experts that will help private industry, that will help guide these things. But we didn't get a lot of detail in there, right? We'll be able to get some detail today and look at some very specific projects that might, we can all decide, be useful for getting back to the moon. So, it's an Intrepid Museum show. You know the drill. You can ask us some questions in chat at NASA Spaceflight. There's instructions down in the lower third. You might be watching all over the place. You might be watching on Facebook or YouTube or the social media channels. We should be over on Twitch as well, right? So ask a question in any of those places, and if it's relevant to what we're talking about, remember, we're going to have a lot of different topics that we go through. We'll pull some questions out of chat, and we'll ask our folks from, or our person from NASA today. But also, since it's an Intrepid Museum show, let's get our other Intrepid Museum person here, Alicia Siegel. Certainly we have you on the show, right?
Of course. Wouldn't miss it. Every month. Hi, great to see you again, Das.
How do you feel about getting back to the moon? Do you think this is like, oh, we've just talked about it, but it's just what you put in a PowerPoint presentation? Have you seen any specific technologies you're like, oh, that makes sense. We actually need that.
It sounds like something out of science fiction, right? Like living and working on the moon. What a dream come true if we can accomplish this. And I believe we will.
Yep.
This is a really exciting topic that we're exploring this month. You know, what does it actually take to transform the moon from just a place that we visit to somewhere that you can actually live and work and do science experiments to learn more. Last year, the International Space Station celebrated 25 years of continuous human presence, living, working in space. They've done so many experiments on not only, you know, things that can improve our life down here on Earth, but also just the human condition and what is it tax on your body, you know, to be able to do stuff like that. But there's so many pieces that have to come together to live on the moon now. Even it's entirely different than space, right? Mission operations, crew support, technologies, payloads, And then, of course, lunar habitats, infrastructure, like this whole moon base that, as you were saying, Jared Isaacman, has been, teasing to us that we're working on. So I'm really excited to actually have this conversation today. We've got a great guest on from Marshall Space Flight Center, specifically the Human Exploration Development and Operations Office, or HEDO. If you've come to Kids Week, you have seen them. They have had a booth at our Kids Week event every year, doing some really, really exciting, interesting experiments on, again, human living. Like what does it take just to live as a human here on Earth? Things you don't even think about because it's just our normal every day-to-day life here. Going to the bathroom, stuff like that. So which is
it always
a
goes
fun,
there. It always starts with how do you go to the bathroom? Yeah. I wonder if people at NASA sort of get like, oh my gosh, there it is again. But as it turns out, it's a very human thing. You have to figure that out.
Everyone asks,
Yeah. There's a specific project we've talked about on the stream before at Marshall. We'll get into that in just a little bit. But let's get our guest over here. You had just said it was with HEDO. HEDO is the acronym, initialism.
Yes.
I always get those mixed up.
So we've got Taylor Goodwin from NASA's Marshall Space Flight Center. She's a program analyst for the, again, Human Exploration Development and Operations Office. Kind of a mouthful there. So again, we'll refer to it as HEDO from here on out for short.
Yep.
And she actually began her NASA career as an intern way back in 2018. Highly recommend their NASA intern program, by the way. It's a great place if you're young and you think you might be interested in learning more about getting involved in the space industry as a career. Definitely check out their internship programs. She could probably tell us a little bit more about that experience too. But she's supported a wide range of NASA programs and technologies, things like Space Launch System, of course, which we hear about all the time with Artemis, Centennial Challenges, cryogenic fluid management, and space nuclear propulsion, and of course STEM engagement. So welcome on, Taylor. Don't look at me, let's look at Taylor. Hi.
There we go. Hey, Taylor.
Hi, thank you for having me.
Well, thank you for taking time out of your weekend to talk to us about the myriad projects you've been involved with. You've worked on so many different things with Marshall and NASA.
Yeah, that's one of the fun things about working kind of in the public relations and communications world, is that you get to touch so many different things and you learn so much about the agency.
Outstanding. Well, we promised that we were going to start talking through a lot of the different projects, and I think that's one of the benefits of your sort of position. You're not an engineer who's worked on one project. You've been involved with a lot of different projects, helping people understand what they are. So we've really got a breadth of different sort of topics we can talk about here today. But I think we want to start with, there was sort of an overview. We talk about going back to the moon to stay. We talk about a moon base, and people are like, oh yeah, well, you just put down a moon base, you're done, right? That's all it takes. It's super simple. What's so hard? I think we had a graphic that showed a bunch of different parts, and I wanted to do like an overview of a lot of the different things that you have to think about when you're going back to the moon. Now, Elise, you said, oh, it's totally different. Well, there are some things I think that are really different between living and working on the space station and living and working on the moon, but there are also a lot of things that are probably really similar, like waste recycling and planning to make sure that your supplies get there on time and that sort of stuff. Taylor, how does that work for you? Do you see a lot of benefit in, oh, I know how to make a plan for the space station, and so therefore I can use that same sort of structure to plan for the moon? Are they really different, or are they similar for you?
So they are different, but like you said, there are a lot of similarities too. And what's great about our experience in low Earth orbit and on the space station is that we've kind of used that as a first step. So we go to the space station, we learn how to live and work and plan and all of these small things that people on the ground would have never thought of because they didn't have to deal with those things day to day. But now that we've been in low Earth orbit, kind of seeing, this is what it takes at this level. And then we start to think about, okay, well, what would it take if we're even further out? And we can't just send a quick resupply mission up. And what if we want to have a sustained presence and have people on another surface for long term? What does that look like? So it's kind of taking these technologies that we have developed over the last 25 years of the space station and now imagining, okay, how much further do we need to advance these things before we're ready to live more independently off of our home planet?
That makes sense. That's a big thing that you actually see that in science fiction a lot. There's the whole, oh, yes, we have a base there, but the only reason it can work is because Earth is constantly sending supplies. It's a big trope, I don't know, theme, but that's something we want to sort of work towards, like the more self-sufficient a base can be. I mentioned recycling, I mentioned consumables, all that sort of stuff. The better off it is. You don't want to have to constantly truck everything back from home. This is a sort of set up a graphic you sent over to us. I love this because it says achieving the vision moonbase, right? With phases. Did everybody see the phases on it?
Phases
and it's
of the
like
moon. Get it?
Phases, yeah. You get it. Talk to us about what we see here. I mean, I see some dates on the bottom. I see a bunch of different technologies or systems. Like, walk us through all the different parts that we have to worry about for a moon base, and then we're going to hop into some of the specific technologies that you've worked with, that you've talked about.
Yeah, absolutely. So Moonbase is going to be a phased approach. Like you said, there's a lot to it. It takes a long time to deliver everything that we need and then slowly build once we get there up to a more sustained presence. So what we have here is an artist rendering of what a Moonbase could look like. So everybody's imagining it. What would this look like? So we are kind of getting some ideas out there, and this is an artist rendering of what it could look like. And you can see some different things on the surface there, and those represent kind of the technologies that we will need to realistically live and work there. So we'll have to have some robotic missions, some cargo landers. So we'll need to be doing some technology demonstrations on the surface to help us develop these technologies. And then we'll be doing all this in phases. So we'll kind of start with the first phase, and we refer to this phase 1 as build, test, and learn. So we will shift here from unique infrequent missions to a repeatable kind of modular approach. So we'll be building as we go. We will have some commercial payload services send up some supplies to get us started. So we'll be looking at advancing mobility. How do we get around? Power generation, communications, navigation, surface ops, and a broad spectrum of scientific investigations that we want to conduct while we're on the surface. Do we have any questions before I move on? I know it's a lot.
Do we have any questions? I love it. This is an interesting thing. Like, you have the different phases here, but one thing that we get a lot, and I'll say this because there is somebody in the chat who is thinking this right now or watching the video right now, and they're like, oh, we already went to the moon. What do we need to do on the moon that we haven't already done, right? And I think a lot of people don't really understand, when we went to the moon for the first time, it was a camping trip, right? We basically took an RV to the moon, but we kind of left part of the RV there, and we came back. It's not really just came back in the truck or whatever, but it was just a one-time trip for very short periods of time. We did it a couple times, but we didn't, like, build a cabin on the moon. We just sort of camped out on the moon. So when we talk about this new moon base, we're not talking about just going back and camping in a moon tent. We're talking about actually trying to, I say build a cabin, right? I don't know if that's, maybe that's not what we should say. We're using, like, lunar wood to build a rustic cabin on the moon. Not really, but maybe we're using regolith. That's a big difference that I think a lot of people don't really understand, like, why we need to go back, right? So what you're talking about here, where you're talking about this more sustained presence, it doesn't start off by putting a condominium on the moon, right? I guess the size of some of the landers are kind of apartment sized, but it's more about trying to build this infrastructure that allows us to stay there, right?
Yeah, that's exactly right. To build the infrastructure that we need to stay, and not just stay and be content with where we are and what we've developed, but to use our experience there to keep pushing, keep furthering these technologies so that we can get even better at living off planet, and then eventually think about where we're headed after this. Can we go further?
So let's jump into a specific thing, right? Like a specific bit of technology. And I'll leave this open to you. Where do you want to start? Like, pick a project for us that you think is really cool that might be useful for the moon.
Sure. So one thing that I would love to talk about is, what people think about actually being on the moon and traversing around. I don't think a lot of people think about what all goes into just the day-to-day logistics. And that's one thing that my team, the HEDO team at Marshall, has really thrived doing. And with this 25th anniversary of Humans in Space, we were also able to celebrate our 25th anniversary of a facility that we have here called the Payload Operations Integration Center, the POIC. So this year we had 25 years of the POIC. This is a 24/7, 365-day operations center, and our team supports science on the space station. So they work a lot of the logistics of the payload on the back end, and they help walk our astronauts through the steps to complete an experiment. They help manage their time while they're there. It's a lot of just day-to-day small things that they do that have a really large scientific return. And we have been operating in that center supporting station now for, when we say 25 years, I mean around the clock for 25 years. So it has been an uninterrupted 24/7, 365-day support for 25 years straight. And that's so... It's such an accomplishment because it's a lot of hard work, and it's a lot of really detailed work, and it's really dynamic, and it can be demanding, but they see real scientific return that they get to contribute to every single day. I think we are now, the investigations that they have conducted with support from this team has gone over 4,000 different scientific investigations done over the last couple of decades. That's a lot. That's a lot of things that, coming to scientific conclusions that maybe we wouldn't have been able to reach in Earth because things work differently in microgravity. And while that's helping us on Earth, it's also helping us think of, what we're going to need in different space environments. So we talk about going to the moon for the first time as kind of a step, and why do we need to go back? This is the same thing with the space station. It's like, okay, we've already had humans in space, so what are we doing going to the moon? It's a completely different environment. And with a different environment, we have so many new things to learn, so many new investigations to conduct and learn about our solar system and the origins of life and all these other questions that everyone is super curious and excited to learn more about. And we're so lucky to have 25 years supporting this science because now we have such a strong foundation to continue doing that just in a new way on the lunar surface.
That's incredible. And I mean, first of all, congratulations, Taylor. Like, what an accomplishment. 25 continuous years. That's a colossal effort, just also of people down here, of course, coordinating their time and their efforts. It's amazing to think 25 years, such a long time. There's probably actually people watching our show right now who are younger than that. There have been people in space. It's incredible. I want to point out too, one of the pieces of hardware that you all have supported for almost that entire period of time is the microgravity science glove box, which I know you were really excited to talk to us about. I think you were saying it was originally designed for just like 10,000 hours, and it passed 100,000. Which, I mean, NASA does this all the time. They say,
NASA.
It's gonna be whatever, but it's like, exceeds its life by so long, which is wonderful. How did it manage to remain so useful for 10 times its original goal? And can you tell us a little bit about that too?
What is
Absolutely.
it?
Yeah. So, we get a lot of questions about this, and it's so interesting. This has been one of my favorite topics to get familiar with the HEDO team. Like Alicia said, this piece of technology, it was planned with a goal of operating 10,000 hours. They're like, if we get 10,000 hours out of this thing, we'll be happy. We'll be so happy. That's huge. And we just passed 100,000 hours. So it has been going for so long, but it's called the Microgravity Science Glove Box. It is a contained facility on the space station that allows the astronauts to conduct experiments that might have hazardous material. So they are safe. The crew is safe, their environment is safe, everything is contained in this box. And you can see it has kind of those armholes cut out there. So they have gloves on the inside, which is where the glove box name comes from. And while they have this glove protection, but they can see very clearly inside what's going on. So they can handle things within the box that they would not have otherwise been able to because it was a safety hazard.
So on station, is this like a chemical that you wouldn't want to get loose in the air of the station, or a biological agent? Like, what sort of things do they test in there?
Yeah, it could be either. So it could be, like you said, something that they don't, like a chemical substance that they wouldn't want on their skin. Or maybe it's something that would break up into a lot of tiny pieces that you don't want floating in zero G and getting in your other equipment. It could be that maybe like there's some dust on there and they don't want dust particles flying out and getting on space station equipment or anything that they would potentially breathe in. So it's just a really good containment. So an extra layer of protection for everybody. It keeps things clean. It keeps everybody safe. And there have been some really incredible experiments done there. And with this anniversary, we're kind of looking back at some of the really cool work that had been conducted in the glove box. And this was, I think, my favorite, but recently with Expedition 73, they conducted something called the fluid particles investigation inside the glove box. And this was a physics experiment that could help researchers understand how particles in a liquid interface, how they come together and form larger clusters while they're in microgravity. And what they learned from this is going to help us advance fire suppression, lunar dust control, and even plant growth in space. So that's just one example of, those are all things that we're looking at on the space station, but those are things that we need to have under control when we're living on another surface.
Well, let's tie this back to the surface of the moon, because the whole thing is here, like, okay, NASA designed a containment box, right? I'm going to call it a containment box, the glove box, that you can use to work on things that might pose a threat to the rest of the facility. Maybe it's not always so dramatic sounding, right? But think about it on the surface of the moon. One thing that comes to mind is lunar regolith, right? And you have this entire set of, I had my spacesuit on, and now I want to get out of my spacesuit and come into the hab. Well, my spacesuit's totally covered in lunar regolith. Well, I don't want to breathe that. I don't want a bunch of moon dust to be everywhere. It's not even like the moon dust is going to settle down onto the ground and then you sweep it up. It's way less gravity. It's going to be everywhere. So if you're working with lunar samples, you're not just putting them in a bag and carrying them back to Earth, but you're actually working with them there on the surface of the moon. You want some way that you can, I don't know, hammer on them or whatever without the lunar regolith dust getting in the entire rest of your hab. Right? So it seems like that's one specific tie-in. It's like, we've got 100,000 hours keeping material A out of environment B. Maybe that's useful for the moon. Am I stretching too much there? Is that sort of like how it ties in?
Yeah, no, you are spot on. So that's exactly what we're doing. It's anything. It could even be, think about if we had maybe something that could be diseased. And you didn't want that getting out. Anything that could affected the immune system of the crew. Yep. So even things that you can't see very clearly is stuff that would go in there and then help it stay contained for safety.
Yeah, I like it because there you can bring in those samples or whatever, and I'm thinking about moon rocks, right? I'm thinking about I really want to hold a moon rock, but I really don't want to breathe a moon rock in. It doesn't sound good. There's no weather on the moon. There's no moisture. There's no flowing water that makes our little sand grains nice and round. It's all really sharp and pointy, and I don't really want to fill my lungs with regolith. So one small thing, it's not like, we got to figure this out. We're not starting from scratch. Maybe there's some special things like the seal has to be different for regolith versus the materials they work with on the station, right? But you've worked with it for 100,000 hours. How many? You said you did 4, not you personally, but there's like 4,000. Was it 4,000 different investigations that the glove box supported?
Yes, so about 4,000 over the years, which is, it's been 24 years of investigations, but yeah, it is so much science, and to think that there are people here at Marshall that we celebrated with for this anniversary, and they've worked on the glove box since the design phase. So they've been here when it was just a thought, and now to see it pass this incredible milestone. And part of the reason that it was able to reach that point is because they've seen it from, they say from the time it was just an idea to the development phases, and then actually implementing science there and recommending repairs and keeping up with the life cycle of certain parts and managing the maintenance. So they've managed it so well and taken such good care of it that it is performing 10 times longer than anyone ever expected.
Yeah, it's very NASA, though. It's always like, oh, yeah, we're going to send a rover to Mars for 3 weeks. Trust us, 3 weeks. And then, like, 11 years later, the rover's like, well, I got a hole in a wheel, but I'm still going.
Still kicking.
I appreciate how some of that stuff sort of turns out. But I have a question. I'm going to go back to the 24/7 operations for 25 years. And I don't know if you can answer this. Does that mean somebody's been in the room for 25 years straight? Like there's always somebody there on staff?
Yes, there is always somebody there at all times.
So I think about like other places, like maybe a nuclear reactor needs that, right? But the number of other types of places where it's like this room has had a person in it nonstop for 25 years. Not the same person. Thank goodness.
Right.
That's a different area of research that you're probably involved with, I think. But I don't understand, like, how do you even do upgrades on the computers? Some of the old screens, like here, they're all flat screens, right? Does this hand off to different rooms, or is there like a backup? Yeah, thanks, Kevin. There we go. These computers or these screens are very old here, but the room looks way different. Does this mean these might be different facilities? What does that mean? Is it truly one room and they just bring in new equipment? Does it have a backup? Like, talk to me a little bit more about how you do that for 25 years.
Sure. So they have so much equipment in there now, actually, that, usually not every single seat in there is filled at once. So they can kind of swap things out as needed without shutting the whole thing down. But they do also have some backup facilities within the larger building that they can lean back on if they need to. But they do, and they're very careful about when they're making updates and repairs to not have any kind of disruption in operation. So it is truly around the clock, and they are really dedicated to everything, all the little details that go into making that possible. It's very impressive.
Yeah, that's one of the things. This is for the NSF viewers. One of the things that we do is we sort of run 24/7 operations with some of our live streams. We have like Starbase Live and Space Coast Live. And we did an Artemis. We did Artemis the entire time, and we've been doing Starbase Live for 5 years. We don't really have a room, but it's like we need to change the network a little bit. And we need to reboot the network or something, and so all the cameras are going to flash, right? And you don't think about all the little things, like poor Bob over here is still on CRTs because IT hasn't got to switch his station out yet. Everybody else has the new flat screens. All the different things that go into just keeping something available 24/7, because you never know when you're going to be needed, right? You have to be there sort of all the time to be on standby. So I think people don't understand how impressive it actually is to have a room that has been supporting a program, a bunch of people, whatever you want to say, for 25 years straight.
I feel like that probably is also just a nice comfort for the people on the ISS too, though, to know that if anything happens at any hour of any day, they can, pick up their phone or, hit their button or whatever and be able to talk to somebody who's always there and rested and ready to go, and can help them. And I would imagine that would be also very important for the moon as well, with, 24/7 ops as well, to be able to support any assistance they would need there as well.
Yeah,
absolutely. It's also important, for the payload developers and the scientists that are actually sending could be their life's work that they're sending to the station. And our facility actually allows them to access their payload if it's running actively. They can access it from wherever they are. So they don't need to be in the POIC facility to be able to see what's going on. They can be anywhere. And our facility is keeping them tied to their science. So they're supporting the crew. At the same time, they're also supporting these people who have spent so much time and effort, money, and sometimes dedicated their lives to solving this one scientific thing that they got up in space. And to know that it's in such good hands and it's being monitored 24/7, I think that that's really important, and also really special that they have such a close relationship with the people that are trying to advance science, whether they are part of NASA or they are a commercial developer. Wherever they're sitting in the world, they've got that support here in Huntsville.
Yeah. I've got a question relevant to what we were talking about real quick. Remember, anybody can ask a question. Just tag us in chat. You don't have to be a member or pay anything or anything. That's not how any of this works. Just tag at NSF in chat, and it puts your question into a little queue. But I saw one here potentially dating some of our viewers in terms of the younger end of the scale. What is a CRT? Kevin, do we have the CRT picture up so we can tell the younger generation how it used to be to make pixels come out of computers? Yes. So the computer monitors there, those are CRTs. It stands for cathode ray tube. Back in the early days when the magic was fresh, we had to use magnets to steer electron beams at a surface that would glow when it got hit by the beam, right? Was it electrons? Whatever. Yes, we're going to slowly zoom in. And so these monitors were these huge things that literally had magnetically steered beams pointing at your face. That's why I don't know if the young kids these days know, like, oh, don't get so close to your screen.
Ask your parents about that.
Ask your parents about CRTs. They were heavy,
I remember
too.
those.
Yeah.
Big hulking things.
And then one day we invented pixels, or we invented little pixels we could make glow different colors, right? And we got flat screens, which are basically... Are there... I wonder... Y'all think there's still CRTs on the space station? Surely there are.
On the space station?
Yeah, like on the space station. They didn't put them all in a Cygnus and deorbit them, did they?
I feel like that would have been swapped by now.
Yeah, I feel like surely they swapped it out, but honestly, I don't know. I've never paid attention to that.
Somebody needs to look at like current pictures of the space station and see if they can, like in a dusty corner somewhere. Shouldn't be dusty. The filtration system's really good. But there's like a corner that has like an old CRT in it. It's literally a question in chat, like what is a CRT? I had a 21-inch CRT in like the year 2002, 2003, and the thing must have weighed 90 pounds to carry, and I tried to move with it. You don't want to put that on rockets. You don't want to put CRTs on the moon base.
Flat screens are way better for keeping payload mass down, I would imagine.
Yeah.
It's the whole, we have more processing power in our phone than we use to land on the moon. Let me tell you about monitors. Monitors are anyways. Taylor, we're going through some stuff. I'm going to grab some more questions from chat, but talk to us about another thing you think is cool and will help us on the moon.
Sure. So another thing that this was a milestone for HEDO this year. It's been a big year for us with 25 years of station. So another thing that our group manages is the ECLIS system, which is the Environmental Control Life Support Systems on Space Station. So they've been helping to develop these since day one, since the station went up. And one of the big pieces of this overall system is providing clean water for the crew. And to do that, we have something called the water reclamation system, and a smaller piece within that is called the urine processor assembly.
There it is.
The UPA launched the station in 2008, and it's been operating since then. And we just recently passed a milestone of converting 100,000 pounds of wastewater into clean, usable water for the last 17 years of ops on the station.
Wow. So how does that work then? How does the station turn all that into reusable water, like in just basic idea here?
Yeah, so they collect condensation and any kind of wastewater, and they run it through this larger reclamation system. And there is the urine assembly, and it has some smaller pieces within it that further break down and clean the water. And one of those is called the distillation assembly unit. So this goes within the UPA. This was added fairly recently, but this had been there for a while, but we added an upgrade to a piece recently. And it took the operability of this piece from just a couple years of operation to 300% of its predicted life. So this one has just passed 15,000 hours of operation, which is another huge thing. And then as part of that upgrade, we were kind of seeing how much more efficient we could make the processing system. So at the time, we were processing, I think, close to 90% of the water on station, and we needed that to be even more efficient. If we're thinking about going to the moon, going further, 90%, we could do better. We're trying to save space, trying to save money on resupply. So they were trying to make that more efficient and get it just higher operation level. And with this upgrade called the brine processor facility, we got to 98%. So that's 98% of all water on the station is fully recycled.
Okay, so that's clearly something that's very important to be able to do on the moon. Recycling, things like that, being able to potentially, I guess, drink it afterwards. I don't
potentially drink it, Alicia.
I mean, is it just water? I don't know. Like, does it have a taste afterward? Have you had a chance to try it? I don't know.
I've not tried it. I think I would, because from what the scientists say, it is actually significantly cleaner than our drinking water here.
I would not doubt that.
Yeah.
I've seen some of our pipes.
Maybe they could start bottling it, selling it as, NASA water.
Oh, yeah.
No, these are
NASA
questions
water.
that people are curious about, though. This is like what people want to know about. But that's incredible. And also, I would imagine that these long-running systems, again, things that run much longer than they were originally expected to, it's probably also giving you guys information about how something works, too, how it ages, how it fails, how the maintenance would need to be long-term as well. Of course, there's a lot of troubleshooting, I would imagine, as well with Artemis 2. For example, you had Christina Cook, the space plumber, right, having to fix the space toilet. Exactly. That was always in the news, always. But that's helpful information, I would think, on the moon as well. Maybe in space, things are, it's fluids, and things are maybe kind of moving slightly different than they would on the moon itself. But that's helpful information, right?
Yeah, absolutely. And that's it's really interesting to see the first iteration of Eclipse that they sent up, and then to see, okay, several years later, now we have another processor that we can add that can make it even better. And then, this part has been degrading. How can we upgrade it to make this thing last several more years? Like, how much more life can we squeeze out of it? So it's seeing how things break down, and instead of just rebuilding the entire unit, finding out, okay, this one small piece, how can we maximize efficiency of this piece to extend the life of the entire system? And that's also the mindset that we'll need when we're on the lunar surface.
Yeah, let me put it into some terms for folks real quick, right? You had said, originally the recycling system. We're gonna sort of focus in on recycling water, right? As one of the many things that is important to do. If you only recycle 90% of your water, right? You got to get your water from somewhere. And if you bring up 100 gallons of water, but you only are able to recycle 90% of it, you use the 100 gallons, you end up with 90 gallons. Then you use the 90 gallons, you end up with 81 gallons. You use the 81 gallons, and I'm not going to do the math from there on out. But you keep sort of like dwindling down if you're only 90% efficient, and it doesn't last as long as you think it does, because it just keeps getting less and less and less. It's like losing 10% every single time you go through the cycle, right? Well, if you need more water, you got to bring it up. Well, you got to get it from somewhere. Right now, we bring it up. We don't pull it out of the vacuum of space. There's no ice floating around the space station, but we have to bring it up. Water's heavy. I don't know if anybody's ever gone backpacking, if we keep going with the camping analogy from earlier, but I used to do a ton of backpacking, and water is one of the heaviest things to have to pack as a consumable for a human that needs to drink a regular amount of water on a regular basis, right? I wasn't trying to recycle any of the water on my camping trips. Was not trying to do that because I didn't have NASA technology. But you need to be able to get the water from somewhere. So if you can go from 10% inefficiency to 2% inefficiency, the water that you do carry with you can last that much longer, right? And we'll get to the moon. There are other technologies. We'll carry a lot of our water to the moon. Maybe we'll start processing our water on the moon. But to get sort of the foothold going, having some way to be super efficient at recapturing the water is super important. Is everybody on the same page as what we're talking about when we say recapturing the water? Any questions, chat?
And I think that's probably something that they would work towards as well. As you said, it does dwindle over time. So, capturing it from other places, I don't know, extracting it from water ice
or whatever.
Water ice, right? Because that's why they're looking at the lunar South Pole. So, yeah, I don't know. And then cleaning that water ice.
Yeah,
that looks like if we find it.
Yeah.
Use the glove box. That's what the glove box is for.
Exactly.
You take the lunar ice, you put it in the glove box. So if there's lunar germs, whatever, I don't think there's lunar germs, but lunar chemicals in it that you shouldn't be getting in your eyes or floating through or breathing in, you figure that out in the glove box first.
There you go.
And then you go from there.
I
made that up. I don't know if that's true. Is that true, Taylor?
Yes.
That makes sense. Yeah.
All right. So recycling, did we... This is something that's been running and being improved on the station for a while, but the station isn't the only place that we don't have to have it be in space in order for us to work on this, right? Do we test this on the ground as well?
We do test on the ground. So Marshall has a lot of testing facilities, and we have the main ECLIS test facility here. It's just across campus. They have a really large laboratory with several different facilities that you can walk through and just kind of see how they are analyzing the system. They have Simulant that they kind of run through it to see how it filters. It's really interesting. It's a massive space, and it's cool to see how spread out they need to be when they are imagining a better solution or how to improve the process, and then to take all of that and condense it into something small enough to fit on the station is really cool.
Yeah.
There's a relevant question in chat here, and there's a little bit of chemistry and physics here. Mimu was asking, can you send compressed hydrogen and oxygen and then recombine it into water? Well, one of the interesting things is in the Apollo missions, they had fuel cells. And one of the byproducts of the fuel cells was water, exactly what you're talking about. But that's not necessarily the most effective way to do it. You don't want to try and generate all your water from base elements. I don't think we're quite there yet. Even though we know we can do it, I don't think that's the most efficient way to move your water around, right? But I think the important thing here is once you have the water, keep it, right? Keep reclaiming it, keep reusing it. And this is another thing, and I'm pontificating a little bit. This is another place where people just don't understand how learning to do things in space can help us on the planet. Because in space, it's tough for us to take more water up there, right? So we need to learn to reuse the water. We need to learn to conserve it. We need to learn to recycle it, to clean it, to make sure it's still safe for consumption, whatever. Well, on the ground, you might take it for granted that I can just walk over to my tap and turn it on. And it's magic to you. Water just comes out of the tap and nobody has to worry about it, right? It's not really the way the world works. It's not really true that water just magically comes out of your tap. There's a lot of science, there's a lot of technology, but conserving and recycling water is always something that we could do a better job of. So we develop a technology like this for the space station, and then it can be applied in arid regions, in the desert, in closed environments. Like there are places on Earth that we can use that, because recycling stuff and being better about the resources that we use in the first place is a huge... People don't like to hear it, right? But it is true. Learning things up there and then using them on the ground to make life better down here. Let's go on to I was going to say go on to another technology. Was there anything else on the recycling, the ECLIS?
Not on Eclipse, but I do have one more point on how our team has kind of developed this expertise in
Sure.
low Earth orbit. So with the Commercial Crew program, we have a team here that's part of HEDO that contributes to Commercial Crew. And when Commercial Crew was standing up, it was going to be the first time in 9 years that NASA astronauts had launched from U.S. soil. So they're trying to get that off the ground. They are working with commercial industry for the first time to develop these new systems that need to be human rated. So we're putting our astronauts on them. We want to be absolutely sure it is the safest version of transportation that they can have. So we have engineers here that helped come up with the vehicle certification qualifications to make sure that the crew was 100% safe for human space flight, and then providing technical support during launches and also during tests before they even get off the ground. And that program officially got off it was in 2020. I don't know if you guys remember that one. That is one of the most memorable launches for me, and I remember I was just watching it from home, but even then it was so cool, and just
We all were. It was the pandemic.
That's right.
We were all stuck at home, and then we see this, and it's like, wow.
Yes. And it was so cool and so inspiring to see us get back to that point. And for that to have only been 6 years ago, we've now launched using this program 15 times to the space station. And that's helping us. It's, when we talk about developing low Earth orbit, it's not just for NASA to practice where they're going to go next. It's also for us to support commercial industry as they become more independent in their exploration journey. So they're learning how to get into low Earth orbit, and we have that decades of experience now, then of course we want to collaborate with them and share the knowledge and do whatever we can to help support them. And then once they get that going, that kind of frees NASA up to focus more on the longer term. We've got trusted commercial partners who are wonderful, and they're doing great in low Earth orbit exploration. So now we can set our sights further out.
Right.
So HEDO really touches on everything that touches on a human, really. It's human exploration, development, and operations. It's literally anything that has to do with human space flight, specifically with the human side of it. And you guys do a lot. I'm impressed. You do a lot.
It is a lot. And there's so much that I'm not even touching on, but it's such a massive portfolio. But you're totally right. And the entire goal, everything that we are laser focused on is how do we help humans not just get off the Earth, but how do they thrive off the Earth?
Yeah. You were talking about the crew program, right? When we started launching with American rockets and American soil, et cetera, et cetera. Did we pull a clip of this?
Oh, awesome.
Do that.
Is that demo too? Oh my God. That's amazing.
But this is what we're talking about again. I mean, NASA had experience running the shuttle, running station on Eclipse systems, and how you keep humans breathing and drinking and eating, and that's all those different things, right? And a commercial provider doesn't have to start from scratch. There may be more efficient ways to do it, more cost-effective ways to do it, especially once you get into scale. But the physics don't change dramatically, right? It's like all of this research, all of this learning, education, development that we've done, NASA sort of reaches out and says, hey, you're putting astronauts in a capsule for us. Here's what we know that might be helpful about capsules. And this is like a success story of that entire process, right?
Absolutely. And one of my favorite quotes when we talk about spaceflight is standing on the shoulders of giants.
Right.
And that's not just one generation of NASA employees to the next. It's NASA helping the whole world. And we've had partners helping us along the way from the very beginning. So it's not just for internal, it's also, we've laid this foundation for everyone. It's for the benefit of all.
Gotcha. I've got some more questions that keep coming through chat here. And one of them is near and dear to my heart. It's about, will there be a live stream from the moon base? I don't think we're quite there yet in terms of committing that there will be a 24/7 live stream. But if y'all need help, we're here. We have all sorts of experience, just like y'all do. But let's talk about cameras on the moon. There was a segue happening
Okay,
there.
here we go.
This was one of the things we were talking about. Okay, we're brainstorming some different specific technologies that might be useful, and the Hulk camera came up, didn't it? Tell us a little about the Hulk camera.
Yes. So the Hulk camera, and it's HULC.
C, not K.
Yes, not K. This is the handheld universal lunar camera. So this is a camera that is in development. It's actually a partnership between NASA and Nikon. And the base of this camera is a Nikon Z9, and it's been modified for extreme lighting condition and temperature and lunar dust mitigation on the lunar surface. So this is a camera that is planned to be on the surface. And for Artemis 2, it ended up being kind of a late edition payload there, but it was a crew preference to have it on board. They were, felt strongly that if this is the camera we're going to have on the surface, like, let's test it out. And we have been testing this model on the space station for a while, but to do lunar observation with it before you get to the surface was really awesome opportunity that we're so happy that they got to cash in on. And we've got some pictures up here of what some of their captures looked like from that camera. I think they turned out really cool.
Yeah.
These were some of my favorite images returned from the mission.
That's the cool thing. This was a big kind of story to a lot of us because, like you said, it was sort of a late-breaking addition to the mission. It possibly rightly, the sort of historical way that things happen, it's like, oh, yeah, we have to certify a camera to go to the space station. We have to certify a camera to go to the moon. And so because of the certification process, sometimes the camera that is allowed to go to the space station is not the newest camera, right? It's not the greatest technology, the latest thing that just came out this year because of this maybe sometimes over lengthy qualification process. Is it safe? Is it going to outgas? Is it going to do this, that, the other? Oh, well, we got to use a 10-year-old camera instead of the latest, greatest technology because we know the 10-year-old camera is good, right? But like you said, it was a late-breaking addition because this is a more modern camera. This was like an opportunity to put not technology that was 20 years old, but technology that was more recent onto the Artemis 2 mission and like get it in their hands, right? I think they did a couple things like that.
Yeah, that's true. And we heard a lot of people say, why this one when there are so many options?
Cameras.
But yeah, this right. And you guys know all about that.
Well, people tend to get very tied to their brand of camera. So you have a Nikon camera, and then all the Canon people are like, well, Nikon, you should have sent it. Like, it's just going to happen with cameras. That is what I'm glad that a camera went, right?
Yes.
But
I was.
Go ahead.
I was just gonna say I was so interested in all the discourse we saw around this camera going, and so many people that are passionate about camera industry in general had a lot of thoughts, and I had a good time reading up on those. And I talked to some of our engineers about, why was this the one out of all the models out there, why this one? And they said that this camera specifically, just the base model itself, it operates incredibly well in low light. And they knew that the tweaks for this one might not be as much as they would have to tweak for a different model.
Right.
And got this working relationship with Nikon going, and it just turned out to be the best option. And since they've been modifying it, they added like a grip and some other things that will help the ergonomics of astronauts actually using it. You think about having a camera and you're clicking with your fingers that are free to move. If you're in a spacesuit with gloves that you don't have that dexterity, so it's a little bit more difficult. And those are some of the things that they're modifying. So they're making it more user friendly.
And yeah, some of the other things like you were mentioning, like a thermal blanket and just modified electronics, the viewfinder maybe being a little bit different. Things again that we don't think about here on Earth. We have our cameras, we're used to them, whatever. But even just something as simple as giant gloves. Like imagine trying to use your iPhone or something with like an oven mitt on.
Right. Yeah.
It has to be a special oven mitt with the little touch thing. It's like touch compatible oven mitt. Which camera did they take on Artemis? I didn't see the big white camera with all the packaging. Was it the base model camera without the thermal shielding and that sort of stuff?
Yes, so they just had the base model since they were inside,
Right.
and they didn't have the gloves on, so I think they didn't need the grip part. But yeah, they just really wanted tested the lighting conditions with this
Right.
one. That was their primary objective there, so they took the base model.
Makes
Is the
sense.
idea to then also like maybe make some upgrades and then take it on Artemis 3 and then, you know, eventually then use the most upgraded version for Artemis 4 on the moon?
Good question. I don't know if it's planned for Artemis 3, but the ultimate goal is absolutely to take it to Artemis 4.
Right. I'd love to see the difference there. Like, I'd love to just do a video about, here's a normal camera, and now I've got on spacesuit gloves, and I can't do anything with this normal camera, right?
Yes.
And so now here are the changes that have been proposed, or we're working on these different ideas to this camera, and now when I have a spacesuit gloves on, I can hold it, the sizes are right, the way that my finger can move in an inflated balloon, right? Lets me press these buttons or do this viewfinder or whatever. I'd love to see more of a deep dive into before and after how that works.
You know, there's more to it also, though. It's not just human like usability. You got to think about the environments too, right? I mean, thermal blanketing, right? Like radiation on it, obviously. But like you were saying before, lunar regolith. Imagine getting those tiny little dust particles inside all of the movable buttons.
Right. Or something that could scratch the lens, or you have to think about all these things when it's just exposed.
I mean, you guys know in the field, right? That's like from an NSF perspective, when there's giant plumes coming at you, and danger bands and things.
We put a lot of cameras in harm's way, like really close to rocket launches, and you go and you pick up the camera afterwards, and you're taking the lens off, and it's like. Because there's so much grit and sand in the lens, and then we've lost cameras. We lost a lens to the Spaceport America student rocket launch competition because so much dust got into the workings. It was a zoom servo lens, and even just in the regular dust in the regular desert, and this was in Texas, West Texas, over the course of 2 days, the zoom function no longer worked because it just got dust into it, and the little dust particles kept it from moving. The servo just couldn't move anymore. So things like that, like how do you solve for that when you're not just in West Texas, you're actually on the moon or somewhere else? That's a huge problem to solve. I like the red stripes too. I don't know if that's it's like this side up maybe, so you know which side is up on the camera.
It could be, I'm not sure.
Yeah, it looks like it's got some retention straps, right? So that it's like sort of on your glove and it stays on your glove with one hand. I bet you dollars to donuts those red stripes are so you know which way is up when you're holding the camera.
I bet you're right.
That's my guess. It also looks cool. Maybe there's like a camera 1 and a camera 2, and like EVA 1 gets the red stripes and EVA 2 gets the blue stripes, and camera 1 gets the red stripes and camera 2 gets the blue stripes.
Oh, maybe.
Color-coded system would be nice.
I need to talk to somebody who's working on this. I want to come hang out with them.
All right, let's talk about more moon stuff. All right, so when you guys, were doing this payload, for example, right? You now also have some new control rooms that you were telling us about, Luca and Lisa, right? Could you, first of all, NASA loves their acronyms. What do those stand for? And what are they? What were they for? Why did you guys start using them for Artemis 2?
Yeah, so we were talking about the Payload Operations Integration Center earlier. So that facility sits within a larger building at Marshall, and the larger building is called the HOSC, the Huntsville Operations Support Center. So this is kind of our ground control from Marshall, and we have the POIC within the HOSC. And then within the last few years, we added 2 new control rooms called the Luca and the Lisa. So the Luca is the lunar utilization control area, and the Lisa is the lander engineering support area. And they're twin rooms, so they look very similar, and they sit side by side. So this one is the Luca. And within the Luca for Artemis 2, we did some payload operations from this facility, which was very cool. So they were supporting science ops from that room. And then right next door in the Lisa, we had teams that were kind of doing a test run. So for surface operations, they will be in there doing real-time engineering support for surface and for lander operations on the surface. So during Artemis 2, they sat in there, got familiar with the space, did some real-time mission observations, and just kind of did like a practice run for the next one.
You're warming up the spaces really for,
Exactly.
for
Yeah,
getting
breaking
ready
it
for the
in.
moon.
I think this is something not a lot of people understand. We hear mission control, right? And it's like, oh, mission control, it's the big room when they're when launching the rocket, right? And then we know about ISS mission control, and it's the room in Houston, and it's the space station main operations. But think about this. There are a lot of specific experiments, like a project, one specific piece of science that they're doing or working on or whatever, that may have its own mission control. And it's not the big mission control, right? There's maybe one representative that's routing messages through, but behind every mission control, there are probably more sub-mission controls that are helping coordinate, helping run these individual experiments, individual programs. This is for the rover. This is for that. This is for the other. And that's what these rooms are, right?
That's exactly right. So our team here is we're the complement to Mission Control in Houston. And you can see on screen here, we have the payload ops directors. So that position is the one sort of in charge of everyone that is sitting on console during support. So they know everything that's going on during an ops period when they're on shift and they are commanding the room. And they have a direct line to Mission Control in Houston. So they can communicate back and forth with them freely. And then we have our payload communications manager. They are also in the room here at Marshall, and they are the main voice between the ground and the crew to discuss the payload ops and the science that's happening.
It's like Capcom is the capsule communicator, right? And
Exactly.
you also have a Paycom, the payload communicator. This is something that comes up on our rocket launch live streams sometimes. You know, when you do the go no go poll, and you hear these people. We love it when we get a go no go poll, but it's like go go go, and each one person saying go probably represents 100 people behind the scenes that are working on something. You just hear one person say go, but that one person says go because of the work of, I say 100. I don't have exact average counts or anything. But all of this stuff that happens behind the scenes to coordinate and organize and communicate, all the different stuff that needs to happen, these rooms are sort of the thing that we're going to need to have more and more of to keep running more and more payloads, more and more experiments, more and more missions, right?
Absolutely. And you're so right. There's so many details, and it goes down to the smallest things that, would never cross my mind, things that I never have to deal with, but things that they have to think about all the time to keep things running. So it is really cool to see how they've developed it. And then, they've got so much more to go for these more advanced operations.
It was very cool that we were able to, I guess, in a way, get like a sneak peek of Lisa, because I'm sure as we start, working more closer towards actually getting that moon base, the phases, we're going to be seeing a lot more probably live streamed from Lisa itself, those hexagonal, neon lights we were talking about earlier.
Absolutely.
But that's neat too. It was also during Artemis 2 monitoring experiments during Artemis 2, right? So you guys had Avatar, which was looking at organs on a chip. You guys might have heard about that. During Artemis 2, I know we were kind of mentioning some of the science payloads. And then also Archer, which I think they wore as well.
Yes, Archer. So if you saw when they were showing the crew in Orion, sometimes they had like multiple watches on. And one of those was the Archer. So it's a wearable device, kind of similar to a smartwatch that does some health tracking. So that was one of the payloads that we helped monitor here from Huntsville.
And those things were really just also, I think, leaning into to the moon stuff. It's looking at what happens to humans in deep space. So the idea of like living and working long term, not on Earth and Earth's gravitational pull, and outside of our own shielding from radiation with our atmosphere, that sort of payloads are really kind of working us towards that as well.
Yeah, absolutely. And we talk about supporting the crew, and a big piece of that is their safety and well-being, and making sure that not just that they have the tools that they need to be successful, but also that they're feeling the best that they can, and we're doing the best that we can to support them physically and mentally, and everything that they need to be able to be operating at their best self and able to carry out the mission.
Have you heard any feedback from those tests yet about any sort of, how it went? And is that something they're going to continue to do, I would assume, for Artemis 3 as well before we get to 4?
Yeah, so Archer, I think, is actually going to be a study. I believe it's planned to continue throughout the Artemis campaign. So that'll be long-term data that they're looking at. And then Avatar, I know that they are looking at the results. I don't think that we've seen like an official findings report, but we'll keep an eye out for that because I'm really interested to see what they learned.
And it is actually, I don't know why in my head I was even thinking, oh yeah, it'll be good for like when they land. Once they land, then the real studies begin, right? 'Cause
Yeah.
then you're really starting to look at what's it like to live and work on the moon long term, not just projecting what you think it would be like.
Exactly. And they're getting kind of like those baseline studies even while they're on the ground, and then they can see what it was like during transit. And then once they get there, it'll be a whole different set of data that they can look at and compare to how they were affected.
That's amazing. So, okay, so we've talked about, keeping astronauts healthy, supporting them on the ground and giving them things like cameras that can, help them, survive the moon and look at things.
And inspire other people.
Right.
Yeah.
Sorry.
But so what's Keto working on now when it comes to actual habitation systems on the moon? We've talked about a lot of these products. Talk to us a little bit about actually living on the moon. What is that going to look like? Obviously, it's very early. These are just kind of projected designs, but what are some things that we're kind of throwing around?
Sure. Yeah. So part of the HEDO group is we have a team that's called the Habitation Systems Development Office, and they work specifically on just what you said. What would a habitat look like? What all does that involve? What does a crew need to be comfortable? What does the ecosystem look like? What does the habitation itself look like? What is it made out of? What's the best kind of material? So they're looking at the very building blocks of a habitat and what is going to make it most successful. You can kind of see behind me here, I've got a little habitat mock-up. So this is a concept of what it could look like. I know you can't see that super clearly, but it's much bigger than it looks, so it would be difficult to pick up.
Yeah, it's a little too big to like hold up in front of the camera like we usually do.
Yes, but you can kind of maybe see that there are 3 different levels there, and there are little astronaut figurines on each one that are doing different things. Like there's a kitchen and a living space, and they're just kind of mapping out, what would that look like? How do they split up that space? And as part of the team's work, they do a lot with industry to see, what are your guys' ideas for habitations in Earth? What are you thinking about? And helping them take those ideas and figure out, okay, this is our idea. This is where we are. What are we missing? Like, what gaps are there that we should fill to be safe and successful if we actually deployed this? And that's where our team kind of comes in with their expertise, and they help find those goals and then think about, okay, what can we do to make it more stable, or how can we configure the room so that the crews can move about freely once they're in there? Just all of these small details. Is this space, are they able to clean it effectively? Just what are all these little things that you need to do to maintain your own home? What would they have to do to maintain it there? And also, what's going to make them comfortable? What does the seating look like? Do they have a place where they can hang out? What are their sleeping arrangements? Just all these little things that they're thinking about. So they've got that, big picture mindset of, what are we doing and how do we make it happen? But then we've also got on the subcomponent level, they're looking at like the very material that would make up a habitat and what would that look like and how do we test it? So we've got a lot of testing capabilities here where they look at what would this kind of material do if, say, it's a like soft good material and it was inflated in space? What would it do once it was there? How much pressure can it handle? Just all of these small logistics that they are going into to see how that would work. And actually, a couple of years, I believe it was last year in 2025, our team was doing some work with Lockheed Martin on a habitat that they have. And I believe we have a video, hopefully, that we can queue up that shows this test.
Oh,
they did
yeah.
a creep test here where they increased the pressure inside this habitat until it burst just to see how much it could handle and see
Right.
how this material behaved. And it was really cool. I think they learned a lot from that. And to have all of these like super slow-mo cameras where they can see at a much more granular level what exactly happened, what was the first point of failure, all of these things. And it's so cool to see that be developed, and everybody loves these kind of videos too. Marshall
Everyone
has
loves
such cool
explosions.
test capabilities, and it's so much fun to watch him back.
Well,
It's like,
I have to say something about it real quick, because some people see videos like this and are like, oh my gosh, what, it blew up. They don't know what they're doing. And people don't understand. You figure out what you're doing by intentionally doing this. It's this way,
Exactly.
actually. You intentionally break stuff like this. You intentionally blow stuff up like this because that's how you find the limit. That's something that SpaceX is famous for, right? See all the different things, and SpaceX sort of leans into it. But the folks out there that are like, oh my gosh, what is this? It fell apart. What a piece of junk. No, you're the reason we don't get cool videos. That's why we don't get cool videos of this. This
They're
is
stress
necessary
testing it.
stuff.
Yeah,
I'm waggling my finger at the viewers. Sorry,
complain
not
about
sorry. It really is important, and this stuff has been happening forever. And as somebody who loves seeing spaceflight advance, I love seeing these sorts of tests to failure happen because they need to happen. You
Right.
have to test things to failure, or you don't know when it's going to fail.
Right.
It's important. Taylor,
Yeah,
I don't know.
absolutely.
It's always a touchy subject, right? But I am so happy when there is enough confidence to post videos like that, because too many people, oh gosh, it just blew up. Why? I don't know what they're doing. No, they know what they're doing because they made it blow up. I cannot
Yeah.
stress that enough.
We saw a headline one time. I cannot remember if it was this or another stress test that we did, but this is my favorite like Marshall test headline ever. It was like,
Yeah.
we had this piece of hardware and we blew it up on purpose.
Yeah, it's like
Intentionally.
people just don't. There's an SLS test, the burst where the tank unzipped on the
Yes.
SLS main tank.
And
You're like,
it's so
oh my
cool.
gosh, what a piece of junk. And it's like, no, that's how you
No.
know what the design can do, because you make one and you intentionally destroy it. That's
Right.
important research to do. That's like a personal pet peeve I have. Like, I love seeing that
Good
video
enough.
and I understand how important it is. But that's a HAB burst test. Like, you want to push that design, that material, that structure, architecture, that process that you even use to make it, right? There's so
Right.
many different things that go into it. And you don't know how good it is until you make it fail, right?
Exactly. And we have a new testing capability, which is it's really cool. So we have the one that we just saw was the burst test, which is it's really fun to watch. It's so cool. That's a full scale test.
Right.
So we now have something. Actually, don't have any visuals for this one because it's very new. But we have a new test capability called the MATIS. It is the multi-axis test bed for innovation structural systems. So
Okay.
quite a mouthful. But the MATIS is this. It's so hard to even explain what it is. I wish I did have a visual, but they test things on a subcomponent level. So they have this bi-actual component with panels, and they can put soft goods on there.
Right.
And when they put it on there, there are these like almost like strips of belts that they have, and they have some going this way and they have some going this way, and we have a team of engineers that goes in and they actually like hand tattoo a pattern on these, and then the strips are pulled and twisted from all different directions, and we have some really, really high def cameras that look at this tattoo design that was drawn on them, and they can see based on how the pattern moves, how the material is reacting to pressure.
Ah.
And this is at
Very
like such a
small.
small level that you can see before you blow something up. You can see what it looks like on a much smaller level. So it's really cool, and it fills a gap. We're talking about finding technology gaps and filling them. This fills a gap between like small testing and taking something all the way to full scale, and that's really important as we're doing this development work because it makes it faster. So we can see things at a smaller level. And
Oops. we may have gotten a loss of signal briefly here. Kevin, we can work the plan to reconnect Taylor. Just 1 second, folks. We had one hiccup when we were testing the show originally, and we went through 63 minutes of the show. Taylor will be right back. We think that it's like the browser refreshing or something like that. In any event, she was talking about the subscale testing. I'm just going to talk until she comes back. We know that she'll be right back.
Well, we can talk. I mean, we actually, I think, did something on. Oh, there we go. That's what we all want to watch.
Roll
again.
the explosion footage again, quick! Distract people.
We did talk about moon habitats. I think a couple years ago on Astro Live, like early generations of this whole inflatable concept. And I think some of the things that they were saying was that it's lighter to be able to bring things up. Oh, she's back.
I think we're back. Are we back?
You can tell me if I'm right or not.
We'll stand by for the audio. Just 1 second. We actually practiced this, folks, just in case there was a hiccup during the show. We learned that from NASA, actually. There we go. Taylor, I think we got you back.
Welcome back. All right, no worries.
Sorry about that, guys. I'm glad we practiced.
Yes.
That's how important the work of Marshall Space Flight Center is
Exactly.
in preparing astronauts. Sorry.
No, we were just vamping here. I was saying that I think years ago we did something on like potential lunar habitats, and it was like right at kind of the start of this idea of inflatable habitats. And I think one of the things they were saying was it's a lot cheaper to be able to send up, not steel beams and things necessarily. You have these soft goods, as you said, and then to be able to inflate it. Is that, I guess, part of the reason why they're really leaning into this inflatable habitat idea?
Absolutely. It's, like we were talking about with Eclipse earlier, it's so much easier not to take up all of our all the space, all of our cargo space with water, and be able to be a little bit more resourceful and find out how to send up just a little and then recycle it. So same concept, we're trying to minimize the size of things. And when we take up less space with things like a habitat or with water, then we have more room for science and experiments and other things that we need to pursue to take up.
That makes a lot of sense. So when we, the moon base, right? This term that Jared Isaacman is now, really
here it is.
Talking about.
We have it on the screen right now. No, so, this is just a rendering, I think, right? What is this?
A rendering.
Okay.
But when we talk about this idea of moon base, that term, what are we actually envisioning? I guess ultimately, or every phase of moon base, is it different? Is it this? Is it like one little habitat, or is it in a collection of the same types, or an infrastructure that grows over time? I mean, in one of the promo images that we were using, there was a rendering with like a greenhouse, and of course, we talk about on the Martian, he's growing potatoes. Like, what does the moon base ultimately look like? Like, what are we hoping to create there? A community?
Yeah, and I think we're absolutely looking to expand it, and that the rendering that we had up there was just one little piece of what it could be.
Lots of ideas.
And lots of ideas, yes, and lots of things that we need. We need things to be able to get around. We need space to live. We need a laboratory to be able to conduct science. So it's all these different spaces, and thinking about how we have this set up. What does our communications look like? Are we going to stream from Moonbase for everyone to watch all the time? Just all these little things. And as we lay the foundation, those will slowly develop over time, and we can see what it could be.
And of course, you've got your build, test, and learn phases. So I would imagine, the things that are being built and tested during each phase. Well, could you walk us through that? Like, what will be built and tested and everything during the first phase, for example?
Sure. Yeah, so for the first phase, we are looking at sending up some payloads. So we'll do that through commercial lunar payload services. I think they are looking to get some LTVs or lunar terrain vehicles up. And then once we're there, they're start looking at how are we going to get around, more advanced mobility, power generation, comms, our navigation, surface ops. So all of those, initial, let's lay the groundwork, is that phase one. So that's building, testing, learning. And then in phase two, that's where we'll look to start establishing early infrastructure. So in phase two, that will be like habitat, some early form of a habitat system could be there, some logistics that support crew operations. They'll start looking to, I think, integrate some more partners there with some like a wider range of scientific payloads. And then once we get to phase 3, that's where we are kind of looking to start seeing, what does independence look like there. So there we would get some human landing systems with cargo capability. They're looking to deliver like some of that heavier infrastructure needed, things like a habitat, and like rovers. I think that would be just like much larger. How do we get those there? That would be in that phase. And then looking at just things that would help us stay longer term. So maybe in the second phase, we had like a really early iteration of a habitat. Well, hopefully by phase 3, we've learned some from that early iteration of a habitat and we're ready to add on to it. Maybe it's different modules or different nodes to the habitat. Maybe it's a different setup. So it's those first 2 are really learning, and then in 3 start to implement the best versions of our kind of taking our lessons learned and turning it into something that's really sustainable for our presence there. And then, phase 3 is kind of indefinite. It doesn't end at phase 3. That's just, once we get to phase 3, we're going to keep developing and keep learning and keep getting better at doing this there.
You mentioned something too that I think is important for people to understand is that it's not necessarily humans doing all of this in phase 1 either, right? Like the role of robotics and cargo landing. Like, can you talk a little bit more about that?
Yeah. So there are some things that could, like we talked about the Mars rovers earlier that went and they were there doing kind of early operations for the surface. So they were exploring, seeing what the surface looked like, mapping things out, seeing what our communication capabilities were between Earth and Mars. So when we get robotic systems there, I think that will be partially what they're doing is, doing some early surveying and testing that will help us get ready to have a crew there, make sure that the site is safe and that's where we want to be, and kind of just dig into the details of, okay, what's realistic for this area? Where do we want to put this habitat versus this other facility? It will truly just be kind of, I think, surveying the area and helping us get ready to add the more advanced systems later on.
I've never really thought about it this way, but I think about it in terms of building a house, right?
Mm-hmm.
And you want to build a house. It's like, I want to live in, I don't know, Georgia. No, nobody wants to do that. I want to live in whatever state, right? You got to start off by finding an area, and we've sort of said, okay, we want to go to the South Pole or here, that, the other, right? So that is sort of zoomed in a little bit, but there's some more surveying work to do. And it's not just, we need to go find the site, but we need to make sure that we can get around, and in our comms work, in our lunar positioning system works, or whatever. Just think about all the different things that we take for granted here that you don't just have easy access to on the moon, right?
Yeah.
So here, it's not like phase 1 is plop down a habitat, phase 1, right? That's not what the plan should probably be. There's some proofing and testing and making sure you're in the right spot and all of these other things before you even get to the habitat. And I love that it's like, maybe we're going to get some rovers down there. Maybe there's going to be some robots down there. Maybe there's a moon drone. We've heard about moon drones falling out of the moon sky or whatever, right? It's interesting because when we say, we're going to make a moon base, I always think, where are we going to plop down a hab? And that's not how it'll start, is it?
No, and it's, also another thing that I thought about with the robotics, they're also looking at the resources that are available at the site and what's close by. So, what resources are available for us that we can utilize and recycle once we start getting things here? How can we start implementing in situ resources to minimize everything that we have to bring up, and then to be sustainable once we're there, help us stay longer? So they're looking at all these different things and different areas that we might want to explore or investigate. So it's connecting all of the things that you would want connected before you moved into a home. Like, would you move in before you had a phone and connection to the outside world? And
Yep.
water.
And also going back to like your camping analogy, Doss, you got to find a good place for your campsite.
Yep.
Not, falling off the side of a mountain or, miles and miles from like water or something like that.
Yep. Apparently there's some people who live in Georgia in chat.
Uh-oh. You made them
I
mad.
apologize. I don't know if I have to because I lived in Atlanta for 8 years, and so maybe my view of Georgia is different than your view of Georgia. I'm sure it's quite a nice place. Like up 400 was quite nice. I like the mountains. In any event, welcome to the show. So that was something, people are like, oh, what's the hab going to look like, and where's it going to go? And it's like, there are ideas being worked on that, but it's not what is the exact hab going to be. It's like, what does a hab need to have? And there are other things that we can do to get the site ready for whatever the hab is. We don't have to know what the hab is right now. And this is me talking, I don't want, here's the perfect moon base, and we're not going to do anything until everything is exactly planned and everything's perfect and everything's ready to go. Like, I like the more iterative approach of, hey, let's get some boots or wheels or whatever on the ground and get a little bit more experience there. And then let's do this, and then let's do this. Like something that leads up to the moon base versus, okay, everybody stop. We're not doing anything until the moon base is perfect. Like, that's not...
Well, because I feel like also like you would be retrofitting things then once you land and you realize, oh wait, maybe this wasn't the best design. So it's better, I think, I'm sure we are going to run into some hiccups and some, like, oh, we didn't expect this quite exactly. And that's better to be able to look with rovers and things like that, robotics, to be able to learn these things ahead of time so we can plan it into the development of it.
Yeah.
Exactly.
Yep. Absolutely. I'm going to go through a couple more things in chat here because we have a couple of questions. We did talk about the machine on the table behind you, Taylor. If we go to Taylor's wide shot, that wasn't a machine. That was like the Barbie Dream Hab, I think.
There it is.
Like a small... I didn't know if you wanted it or if I was going to use it, Alicia.
Yeah.
That's just an idea. Nobody should screenshot that and be like, oh, NASA Moon Hab plans leaked. Like, that's not what that is. That's like a concept. Tell us a little bit more about why that exists. Like, why did we make a model? What do we learn from making a model like that?
Yeah, so I mean, it's a good way to kind of visualize what they've had on paper, and also to be able to share it with folks. This one actually sits in the common space of the office where the entire habitat development team is. So they can look at it to see, this is like a more tactile version of what we're talking about on paper. So they can look at it and think about, okay, well, we have this much space for the bedroom, and not that these things are perfectly to scale, but let's say our astronaut model, they have it in the bedroom and there's not as much space as they would envision having there. So
that looks uncomfortable.
Once they have things a little bit more to scale, it's not flat. So it's just a 3D way to kind of help them have a better idea, bring it to life, I guess, and help them see what they're working with.
It's almost like a brainstorming sort of step, right? Like, okay, I've drawn this on paper in 2D, and then here's how it is in 3D, but here's something that we can, like, move the little astronaut dolls around. I'm kidding. But it just gives you a different way to look at it. Is there anything like VR? Is there a Lunar Hab VR setup that anybody's working on, that y'all are working on?
I don't think that Marshall has one, not that I'm aware of. We do have a VR group here that very well could be developing that, and I'm just not aware, but they have done some really cool work on VR for the space station at Marshall, and I believe at other centers too, but they use that in training sometimes, just to put the goggles on, and it's like you're inside the station and you can interact with things and grab them and move them and kind of see what that would be like and get oriented. So it's a really helpful tool. It would be awesome if we had one of those, especially as we continue to develop it, and then you can have people, walk around virtually just sitting in the office. That would
We
be
had
awesome.
a simulator like that at Intrepid, actually. It was a
cool.
that you could look at. I would imagine too, as we get closer to actually producing this on the moon, they'd probably start running like analog, experiments with like an actual full scale hab that people could, live in for a while and go, oh, this is great, but every time I stand up, I hit my head on this one thing, and like, could you just move that 2 inches or something like that? Like realistic feedback from people.
Yeah, and we have a couple of mock-ups here at Marshall that are in development. They have been for a while, but there's some habitat mock-ups here. They're still in early development, but it's cool. It's a space that is, it is not to scale of any, habitat that's been on paper. It's a fairly generic version, but it has 3 levels, like our model here, that you can walk up and down and see, this is what our living space would look like, and this is what our kitchen level would look like. And the walls are reconfigurable on that. So you can unhinge them and then move it to make one room a little bit bigger, a little bit smaller, just kind of see what it would really be like if you were a person in a room.
It's like modular even, and they could sort of redesign it to their own needs. That's cool. Just out of curiosity, on the model behind you, because like the moon has some gravity, of course. So is it the fact that it's 3 levels up and down like that, is it like ladders? Is it stairs? Is there a reason that they would have chosen one or the other, out of curiosity?
I believe that this one, actually, I think that it is...
Is there like a fire pole that they can slide down?
A lunar fire pole.
That's a pretty good idea. I think that it's stairs. I'm not sure if there is a reason one way or another of stairs versus ladder. I think they could probably like make it make sense for both. And I think about, just like the layout of a house. Like, why do some people have a spiral staircase versus just a regular staircase?
Or straight staircase versus one that does a 90-degree dog leg.
Yeah.
Are there interior designers that work with you guys for this stuff?
I don't think that our team has any interior designers. There could be some that are consulting.
I don't mean for like
sure.
Wallpaper and drapery.
The wallpaper.
Like logistics of like feng shuiing it or something. Like it's like best way to like lay out internal spaces is what I meant.
I was thinking about that last night actually, because I was looking at some of the HAB stuff and thinking about what would make me comfortable, and we think about what they need, and a lot of it is technical, like how much space do you need to get around your crewmates, but also like what is going to make them comfortable in their environment. So that is something that they will absolutely have to factor in eventually.
It is a really interesting idea, though. Like I know with one of the commercial space stations that's they're building right now and looking into is they wanted to incorporate wood paneling because the wood sort of makes you think of
warm and cozy.
And everything. Right?
Don't go there. You should not use wood. Choosing the right wood for your flooring is a problem. It takes too much time. It's going to slow down the space program if we all have to decide on what wood matches the interior.
The right colors, gotta match things.
This one's too yellow. This one's too red. Yeah, that one's too dark, but it coordinates with the cabinets. Like, can we just have white floors or something?
It sounds like this is a personal topic for you, Todd. That you've
I stubbed my toe on flooring samples on the way up to the show today. That's one of the things I was going to say. You have the model, you have the human-sized mock-ups where you can sort of rearrange things. Having physical things like that is so important because you can't stub your toe in VR. You can't bunk your head on something in VR, right? So many cool things that you can do in this virtual environment. Somebody's going to link me to the thing like, oh, here's Head Bonk VR Simulator. Actually, it's all about bonking your head in VR. I'm sure that exists. But there is a place for these physical models and having real humans moving around in real spaces, sort of feeling how they work. And I know sort of getting to that point with the ideas, the brainstorming, and then sort of final designs, that's going to be a huge, interesting thing. And I know tons of people are super interested to start seeing the insides of some lunar habitats, right?
Absolutely.
So we have already gone over our time a little bit here. As we do quite often, we get into a conversation and there's so many different things, especially Taylor, somebody who's involved with so many different projects like you are. There are so many different things that we can talk about, but we are at the end of our time right now. I'll ask, is there anything, like a super cool thing that you've worked on that we didn't quite get to? It's like a door hanger, sort of, gosh, you're going to be able to show me, oh man, I wish I had said that.
I think we did a really good job of covering most of the bases here. I think we hit a lot of the highlights.
All right.
Great.
Good deal. Alicia, did you have any burning questions? That was actually one of the questions, testing fire suppression in that, but that's a whole other thing. Lighting fires is a very human thing to do, but that's also, we set fire to Cygnus spacecraft for that reason. So different show. That's a different show. Yeah.
No, I guess the only other thing, just, if you're willing to just spend another just 2 minutes or so talking about this. You started off as a NASA intern, and I know that you mentioned Centennial Challenges.
Yeah.
And it kind of gave you a full circle experience in what you're doing now. So I just wanted to give you an opportunity to maybe talk about that.
Thank you. Yes, this is one of my favorite things to talk about, actually. This would have been a good one to say I forgot.
Nice.
But yeah,
That's all good.
I started as an intern in 2018 with a program called Centennial Challenges, and this is a public competition platform that NASA has utilized over the years. And when I was interning, we had this competition called the 3D Printed Habitat Challenge. And this was a challenge that it challenged the public to think about what a habitat would look like, what a future habitat would look like. And they had requirements that the hab needed to be autonomously 3D printed. So the idea was that they built a 3D printer. The 3D printer for filament, they would utilize the regolith from the surface that they had landed on.
Nice.
So regolith or waste from your vehicle. So those are the materials you had to work with. And then once it was there, surface, it had to be able to run completely autonomously. So the thought was that you would launch like a 3D printer to another surface, and that it would utilize in situ resources to print a hab that would be ready for a crew by the time they got to the surface. So really cool concept. And we had all these teams that went out, and the first phase of the challenge, they get on paper what they think this would look like. And then if they make it to phase 2, then they develop a prototype of what this habitat would be. And then the final phase, we had all these groups come together, and they had to autonomously 3D print a habitat using Regulus simulant.
Mm-hmm.
And we got to stress test those habs. So we did a couple of different ones. It was so cool to see, but they had one that was like a debris field test. So we had people get up. We were at the Caterpillar facility. They were our partners with this, the Caterpillar facility in Illinois. So somebody got up on some equipment and they threw shot puts down at the habitat to see if it would break. And then we had these colored smoke bombs that they had a little opening in the top. You drop the smoke bomb in and then see if the colored smoke leaked out of the sides to see if there were any leaks in the structure. And the final test, we had a large piece of construction equipment, and it pressed down on the hab and measured the pressure until it splintered and broke.
Nice.
And it was so cool, so much fun to see. And back then it was such a far-fetched thing of, we know that we're going to need this, but it's so far out. We're thinking about what could even be possible. And we got such good return from that. And it's so cool that now it's turning into a real thing that I'm now involved in again. The habitats, when I was just learning NASA and it was just an idea, and now I'm several years into my career and it's real, and it's so surreal to see that come full circle and be in a position where I'm still dealing with that and imagining all the time, what would a habitat look like in space, and we'll get to see soon.
That's too cool. If you're watching, you haven't heard anything about the Centennial Challenge, you could look it up. Just look for NASA Centennial Challenge, and you'll see them crushing the 3D printed habitats. There's like a big excavator or something like that. I didn't see video of them throwing shot puts at it, but I would love to see that. Big fan of it.
I'll send you some. Yeah,
nice
some good stuff.
destructive testing. It's so cool. You go from, I'm in school and I'm going to build a bridge out of toothpicks and marshmallows or whatever, right? You've done that. How many of you hopefully got to do that in science class? And it was balsa wood or straws or toothpicks, and I'm going to build something, then test it to failure. I still have my bridge from high school over here because mine didn't break. But do things like that, and it happens at NASA too, where they're building these things, and it's like, here are these novel new ideas, or we're testing it out, or here's a new process, and now we need to test it to failure because it's cool to see, and we learn get good data from it, right? It's just so cool to see that you were able to get involved with that, and then Taylor, go on to a full-on sort of blown career here with NASA, that you've been working on so many different products. I need to say, I say products, projects, things, cool things, whatever. There's no way we can get to all the questions, y'all. There are so many different things that we sort of touched on here. Some of the questions that are in chat: what are the remote work opportunities for people who might be able to work on things on the moon? There's talking about the ladder. We mentioned the ladder, and it's like, well, you can't really carry supplies up a rope very easily, right? You have to have it on a backpack or something. People talking about how inventory might be taken in a lunar hab. Like, what are they, RFID things? Is it a barcode system? Like, how do you know what moves in and out? Like, there's entire shows that we could do on one teeny tiny bit of technology. But and
we will.
We
when
will.
we get to that phase.
We work on
We're
it.
not at that phase yet.
Somebody's talking about refinishing furniture on the moon. It's like, well, if you got to recycle stuff, like I'm going to be the lunar refurnishing place or whatever. But that's the cool thing here. We wanted to talk about a bunch of different things that Taylor has been involved with, or has talked about, helped communicate with NASA's NASA Marshall. And we wanted to sort of just touch on a lot of the different ideas, because so much stuff goes into a moon base, or anything. Going anywhere has a bunch of different stuff that goes into it. But there's so much learning that's already been done. There's smart people. There's research and data. There's materials that have been designed, processes, whether it's how do I filter waste out of my urine, or how do I keep a team running for 25 years straight, right? So many different things need to go into this. And the good news is we don't have to start from scratch. We have so much good experience. I say we. I'm going to take credit for it, right? NASA has so much good experience, so many talented people, so many good ideas that can be helped. They can be used to help us sort of, I said, jumpstart this moon base. So Taylor, thank you so much for your time today. You just brought us like a smorgasbord of things to talk about. We really do appreciate it.
Yes, thank you guys so much for having me. I've had such a good time. I love talking to you guys. Could talk about this all day. And
excellent.
Would love to send another person from our team as things keep developing later on. Maybe we'll have an update episode.
Absolutely. We could talk about RFID scanners.
There you go.
Inventory logistics.
Elisa and I need to come to this facility and like tour some lunar habs, or I don't know, help with the ecosystem or something like that.
We would love to have you guys. So let me know when next time you're in Alabama.
Nice. It's gonna like lock us in a hab. All right, we're gonna lock them in a hab for 3 days and see if we want to like throttle each other at the end of it. Okay. Again. Folks, it's Taylor Goodwin here. Taylor's from NASA's Human Exploration, Development, and Operations, HEDO office, program analyst over there. Thank you so much for taking time out of your weekend to just chat cool space stuff with us, Taylor.
Absolutely. Thank you guys so much.
All right. Alicia, you had mentioned we do a lot of these different shows. Maybe we'll do a follow-up with the HEDO team here. But talk to us about the next show we've got coming up.
Yeah, well, so first of all, before the next show even, if you are in the New York City area, just a reminder, we've got the last of our free movie nights up on our flight deck this summer, coming up on August 28th. All summer, we've been leaning into the America 250 theme, of course, celebrating the semi-quincentennial of America. So with our themes. So our last movie of the summer is a classic, great for the whole family. It's An American Tale, Fievel Goes West. So please do come on out and join us for that one. And then, of course, us Astro Live wise. Next month, we have a very special on-site event. As you may know, every so often we do these astronomy night events on site. But for you space fans out there, believe it or not, September 17th, which is a Thursday this year, is the 50th anniversary of what should be everyone's favorite space shuttle orbiter. I think it certainly is mine. This lovely one right here behind me. I know a lot of people have very strong opinions on their favorite shuttles, but regardless, we'll be celebrating 50 years since the rollout of the Space Shuttle Enterprise, which demonstrated the feasibility of reusable spacecraft way back before it was commonplace like it is today, and also paved the way for 3 decades of shuttle missions. So you won't want to miss very, very special astronomy night at Intrepid, right underneath the Enterprise herself, commemorating this very historic milestone with some very special guests who will be discussing both the legacy of the shuttle and also the next 50 years of exploration at NASA. So as always, head on over to intrepidmuseum.org to learn more about that. And hopefully you can join us September 17th.
Lisa, you're not actually on the viewing platform in the pavilion, right?
No.
that's a you're at home, and that's a picture behind you.
Yes.
But that is where you can stand. Like that is the viewing platform, and it's like some stairs, and you can go up. And
too.
Yeah.
Wait, that one. This photo. You can literally get nose to nose with the space shuttle. So come by and visit us if you want. It's a free event. September 17th. It's a Thursday.
Good deal. Folks, I've seen all sorts of people supporting what we do. I got to say thank you to everybody who shows up for these, who sends links to their family, like all the different ways that you can share this. I saw some people supporting Intrepid directly. Thank you all so much for that. Remember, the Astro Lives don't just happen in a vacuum. Haha, space joke. Astro Lives supported through a NASA cooperative agreement awarded to the New York Space Grants Consortium. It's been going on for years now, and one reason that it keeps going is because y'all keep saying that it's valuable. You learn stuff. It's good information for you. It's interesting guests. We're not sitting here like just showing you slides. We're talking about things that as space nerds we really think are interesting. But thank y'all so much for joining us today. That is going to be the end of our show talking about jump-starting a moon base here with Intrepid Museum's Astro Live. Also, remember, as soon as the show's done, you can send a link to your family if you're like, oh, wow, this was actually really interesting. My dad might like this, or my brother, or whoever might like this. You can send the link over to them, whatever
or mother
social...
or sister.
Thank you, Lisa. Yes.
Daughters.
I can just keep going down the list. But whatever social platform you are watching on, you can send them the Facebook link, send them the YouTube link, whatever, an X post, whatever you want to do. One thing you can do is help get the word out that there are hardworking people who are super smart and they take time out of their weekends to come and chat with us and tell us about the projects that they work on at NASA and missions and that sort of stuff. So,
and also maybe you were a little inspired by hearing Taylor talk about her internship opportunity. So internships are definitely a thing with NASA. Definitely look into that. And if you're interested in getting involved in the space industry in some way, shape, or form, lots of opportunities with NASA internships as well.
Yep, 100%.
But that is... say that either.
No, they didn't? Nice.
No.
That is going to be the end of our show here today. We went 15 minutes over. We need to let Taylor go. Thanks, everybody, for watching. We'll see you on the next Astro Live. We should be out there for the anniversary of Enterprise. But for now, we'll see you nerds later. Appreciate you.
Thanks, guys.
And here we go.
There's the W. Here's ignition.
Doubling up.
Did it just do a Kerbal?
Back to the moon and beyond.
Put that in the big bag, Jingle.
Back at home, we all have a lot of work to do, but from here, it sure looks like a perfect world.
Propulsion continues to be nominal.
We did have an observation. 343 unfolds to go.
It's orange.
Water towers, fly!
Bingo! Right in the center. Where's Jacqueline? There it is!
That was surreal.
That's not what we want to see.
No!
Oh my God.
Yikes. You bet. We don't need any more of these.